The next item on the agenda is to discuss the procedures following a vibration exceedance, where, as far as defining what that exceedance is, typically because we set the trigger threshold at 80% of the allowable limit, you would get notified of a vibration event at some level that might or might not exceed the trigger threshold. The way that the vibration exceedance is defined in the special provision, it's a vibration level that could be modified from the original SP limit of 0.2 inches per second if the vibration consultant has established a lower limit. Usually when we do a lower limit, it's also a frequency dependent limit where it's, if it's a historic structure, we may in some cases call for it to be 0.12 inches per second until you get up to about 10 hertz, and then it increases because we're not as concerned about the high frequency vibration amplitudes as long as it never exceeds 0.2 inches per second. But we also point out that any frequency that's greater than 100 hertz has a very low likelihood of causing any kind of damage to a structure, because that's usually a much more localized vibration event. It's something like somebody dropping a hammer on the floor next to the transducer is going to produce a high frequency spike of vibration, but it's not enough energy to transmit throughout the structure and shake a wall enough to crack it. So each triggered event has to get reviewed. The vibration limits are determined by the qualified vibration expert after they've gone through and looked at the structure and has said, okay, 0.2 inches per second is okay, or we need to have something lower. It gets added to the contract documents if it's accepted by the engineer, which is part of the way the SP is written. And then in no case should it exceed 0.2 inches per second, again with our caveat that you shouldn't really need to worry about anything greater than 100 hertz in frequency. The SP calls for it to be measured at or in very close proximity to the monitored structure, which could mean that you could mount it outside the structure, or you could mount it in the structure. And then it also calls for an alarm system to signal any vibrations that exceed 80% of the limit. This is where we get to the emails that I thought I had before. When you get an exceedance alert, the initial alert is basically indicating you got a vibration that's greater than 80% of the limit. You get an alert that is sent off automatically by the monitoring system or the server that's receiving the data coming in. You get emails. You get typically, with a vibration event, you get two emails. One is because the first file that comes in from the seismograph is the log file that had been accumulating. And we get the question a lot initially from the contractors and DOT when they get the first alert notifications, because you get two emails. The first one is from the log file that began usually in the middle of the night, so there's a very early time on this. If you look at this first one, the time on this is 21:13. That's at 9:13 in the evening. That's when that seismograph in particular uploaded its last log file and started a new log file. Or actually, no, this is 2026. That's 8:26 in the evening is the histogram file. That began on the 6th at 2026. And then as the system is collecting data and gets a triggered event, you get a second file. You get the waveform file. In this case, there was less than an hour between the initiation of the log file and this waveform file. A typical email that you get will include the date and the time that the file started. There's an identification of the serial number of the seismograph here, and then a file name that's assigned by the software. When that extension on the file name has an H in it, that means that was the histogram file. If it has a W at the end, that means that's the triggered event file. And that's how we distinguish what those files are. And typically, when there's a triggered event, you get, usually first, you get the a notification about the histogram file, because that also included that amplitude that triggered the event. And then you get the waveform file. You can see at the bottom that the information that's included in the email gives you the peak particle velocities in each of the three directions, the transverse, vertical, and longitudinal. It gives it to you in terms of the particle velocity inches per second and the frequencies that were associated with that. And you might notice that the transverse vibration amplitude had a frequency that was greater than 100 hertz. When the seismograph is continually collecting its data and evaluating the frequencies, if the frequency of the vibration is higher than 100 hertz, it doesn't try to evaluate it. It just says it's too high. It's scanning at 1,000 hertz. It should be able to go up to 500 hertz, but it doesn't really report anything if it's greater than 100, so it just gives you that indication. But that lets you know that that vibration is a very high frequency and would not be significant to the structure. Once we get the notification of the exceedance, the SP calls for the contractor to stop any vibration-causing activity and to resume work if the reported values are below the limit. So they get the email, they can see what the amplitudes and frequencies are, and they can tell that, oh, I'm above the 80% line, but I'm below the full project specification. And according to the special provision, they could resume work, just being aware that they caused the event. And then they're supposed to notify the engineer, that being DOT, if the limit is exceeded. That should be something that's done by the contractor when they get the notification. Then the vibration monitoring contractor, which would be WJE, review the triggered event. And we determine the status of the event as to whether it's really exceeding the project limit or not. And it's relatively simple. If it's a high frequency vibration, like greater than 100 hertz, we'd say, well, no, that's not a problem. Or if we see right away that it's below the project limit, we can say, okay, well, you had the triggered event, but it didn't exceed the limit, so we can send an email saying that it didn't exceed project limits. And it's just kind of letting everybody know that the system is working, you're producing vibrations that are near the limit, and just take that into account to change your procedures to try to avoid that. And then we provide our results of our review to the engineer, and the engineer determines the work status as to whether that's acceptable and the contractor can resume or not. There are factors that affect the non-exceeding event that may lead us to indicate that it's a non-exceeding event, and that's if the frequencies are too high to be of concern, such as something greater than 100 hertz. There may be some other causes for that, some electrical interference, or somebody dropping a tool next to the transducer or on the transducer, or somebody bumps the transducer a lot of times. And if they bump the transducer, then we have a concern that they might have knocked it loose from the ground, and somebody might need to go look at it, but it's not a structurally borne vibration that is affecting the building, or the static electric discharge from the refrigerator or the dehumidifier, or lightning can produce static discharges that can get picked up, or RF interference from walkie-talkies. Have the high frequency transients caused by a localized impact, and any other frequencies that are greater than 100 hertz generally are not producing enough displacement in the structure to put any strain on the structural elements. So they're not really a matter of concern. They're more likely localized. And then there's a frequency dependent limit that we talk about, that Arnie talked about earlier, where we are concerned about the low frequency vibrations, but as the frequencies go up, we're not quite as concerned about it. This is just showing a little bit about how the seismograph is looking at the data. It determines the peak particle velocity from the time history that's recorded, and from that it's measuring the frequency. And the method that it uses is called a half sine zero crossing method, where it takes this digitized waveform file and looks for peaks and valleys, and every peak it goes goes back in time and forward in time to find where it crosses 0, and it says that's a half a sine wave, and then calculates the time for a full sine wave and reports that as the frequency for that peak. It goes through and finds every peak and every valley and just pulls out the maximum peak and the frequency that was associated with that peak from this half sine 0 crossing method. And what happens with that is sometimes you have a high frequency vibration which produces a maximum but is riding on top of a low frequency, and it might not cross 0 till several cycles before and several cycles after that peak. And it'll show it may show as a low frequency, it may show as a high frequency. You don't really know for sure how the software is going to interpret that waveform, because it's all done just digitally through a relatively simple mathematic process, and it doesn't go back and look for underlying frequencies. In this case, we have a vibration waveform from an impact. It's a fairly localized impact. It's somewhat high frequency in that the predominant amplitude is at about 50 hertz. If you have 40 hertz here and 60 hertz here. But there happened to be one cycle of vibration in the lower trace, I think, would be the transverse direction, where there was one cycle of vibration that was over the German DIN line 3 vibration limit. And if we had to interpret that based on that criteria, we'd have to say, well, okay, this one exceeded that limit, if you want to be really strict about it. But it was one cycle of vibration in that entire waveform. Unfortunately, that would be considered an exceeding event if that was the vibrational limit. Here's an example. It's relatively easy to conclude that somebody kicked the transducer here, that it's not likely that the structure actually moved that much. That would indicate a maximum velocity of like over 1 1/4 inches per second. That's the full scale range that seismograph is set up for. Then when you have an exceeding an event, that's where the vibration amplitude actually did exceed the project limit. The contractor has to identify the cause of the exceedance and modify their procedures to avoid exceedances or provide recommendations for using different equipment. That different equipment may be different monitoring equipment because after investigation of the event, we may find that the equipment didn't record properly or may have been damaged and was not reporting properly. Or if we can verify there was real vibrations and we can identify the cause of it, they may have to come up with different construction equipment that has to be approved by the engineer. So, got any questions about that?